Hi everyone, I'm Jie Xu I'm an assistant professor from ECE. I'm going to talk about this project, Security-Aware Incentive Design for Cooperative Networks. And this project is supposed to be game theoretical, but I'm not going to show you any equation today in light of time. Rather, I'll be focusing on the motivations and the general framework. So the well-functioning of many networks relies on various levels of coordinated behaviors of its users. For example, in mobile ad hoc networks, users can forward traffic for other users. In cooperative sensing, users can share their sensing results to improve their sensing accuracy. In all these so-called cooperative networks, undertaking these cooperative actions is actually costly, for example, transmission energy consumption, but it brings no immediate benefits to the users who provide the cooperative service. So absent incentives, these users, selfish users, will be unwilling to cooperate. Thus, these networks may fail to work. So a central theme of this literature on cooperative networks is the design of incentive mechanisms to promote cooperation and thereby achieving specific network level objectives. So actually, there's a variety of incentive mechanisms already proposed in the literature. I'm not going into detail, but despite the different forms, the key idea is really similar. So basically, the users have to obtain satisfactory benefits that can at least compensate for their cooperation costs, right? So users are determining their cooperation action or the cooperative effort level based on the careful benefit cost evaluation. Right. So in the traditional incentive mechanism design, they consider costs that only depend on users' own actions. So it doesn't depend on the other users' cooperative actions. For example, energy consumption, it depends on how much traffic a user is willing to forward for others. But the security cost is really quite different from the conventional costs because security risk is often interdependent among the users, and security cost is really a result of the collective behavior of all network users. So without fully understanding how these interdependent security risks emerge in cooperative networks, how they shape user incentives, and how do they affect the eventual incentive mechanism design, simply applying existing solutions can lead to great performance loss or even damage to both individual users as well as the overall network. Okay. So in this project, we try to tackle this security-aware incentive mechanism problem. And we propose a general framework, and in particular, we formulate a novel Stackelberg game with one leader and multiple followers. So in this Stackelberg game, the network designer will play as a leader who will design the incentive mechanism. For example, if a mechanism is payment-based, then the designer can design the payment function. The users, there are multiple users, they will play as followers, and they're going to choose their cooperative actions or cooperative effort levels. But different from conventional Stackelberg game, the users are not only playing best response to the leaders, which is a network designer's move, but also they're playing another game among themselves because of the interdependent security risk. So here we are really solving two coupled games at different levels. Okay. So another issue in this framework is how do we model the interdependent security risk? Right now we are focusing on epidemic models. So for example, the self-replication malicious codes can be inserted into the data exchanged in the cooperative process. So a user can be compromised if it chooses to cooperate. And furthermore, the user becomes a new source of attack when it interacts with other users in the future. So the security risk can propagate across the network. Right. Now, in light of time, I just show you one result for a specific case. So we're studying a random mixing-based epidemic model. And I call this result a more or less result. And also here, the designer is using a payment-based incentive mechanism. So here we can show that if you increase reward provided to the users, it promotes cooperation, which is kind of intuitive. But surprisingly, on the other hand, too much reward can also harm the overall network performance. And the reason is if you have too much cooperation, then it can potentially foster persistent epidemics, which is a risk in the network. So basically, we want to show security-aware incentive design is very different from the traditional incentive design. And we have to, consider all these different features here. Thank you very much.